Alright, so in this video we're going to be graphing quadratics in standard form. The standard form of a quadratic is y equals to ax squared plus bx plus c. Alright, and the graph of a quadratic is called a parabola. A parabola can be either upwards facing or downwards facing, and that depends on the a term. If the a term is ever positive, then the parabola would be upwards facing, and if the a term is ever negative, then the parabola would be downwards facing. All right, so if we're given, say, y equals to negative 2x squared plus 8x plus 1, the a term over here is a negative 2, the b term over here is a positive 8, and the c term is a positive 1. And since the a term is negative, the graph of this quadratic would be a downwards facing parabolic function. And before we go into any process to graph this quadratic, let's go over some terminology. So the first step to graphing this quadratic is to get something called a vertex, which is the very top point over here. All right, so the point where the graph starts would be called a vertex of the parabola. And the vertex has a location of x comma y, which we will obtain in a few. And the value of x is called the axis of symmetry. Upon graphing the axis of symmetry, it's a dashed line, it's an imaginary line. It's not part of the graph, it's just a symmetric line upon which the left and the right are images of each other. And this line is called the axis of symmetry, which we denote as the AOS. All right, so the axis of symmetry has an equation, and the equation for it is x is equal to negative b over 2a. And that's our very first step. The first step for graphing would be to get so let's write that down. Step 1 is to get the axis of symmetry. And by us getting the axis of symmetry, we pretty much also obtain the x value for the vertex. So let me put that down. So, or the x value of the vertex. All right, so there's a formula to obtain the x value for the vertex, and that formula is x is equal to negative b over 2a. And this formula would be all you would need to graph a parabola. All right, so let's plug in our a's and b's into this formula, which we have negative of the value of b is an 8, and over twice a, and a is a negative 2, and negative 8 divided by twice negative 2 is a negative 4. So negative 8 divided by negative 4 gives us a positive 2. And that means that the equation for the axis of symmetry is simply just x is equal to 2. All right, so that's step 1. We got two things. We got the vertex's x value, and in the same step we got the axis of symmetry. And let me graph that on the right-hand side on the bottom so we can start the graph off. All right, so once we obtain the axis of symmetry, we can graph that. And graphing linear functions, to graph x is equal to 2, you go to 2 on the x-axis, which is right here. Yeah, so 2. And then make a vertical dashed line going through the value of x is equal to 2. All right, so this is not part of the graph again, it's just a line that we draw to see the symmetry. And from there, the next question would be that where on the axis of symmetry would the vertex be? And that would lead us to step number 2, which is to obtain the y value of the vertex. All right, so to get the y value of the vertex, this is a pretty simple step. You just have to plug in the value of x that we obtained in the previous step. We obtained the x value of 2, so to get the y value for the vertex, you plug in the value of x of 2 in place of every x in the original function. So y is equal to negative 2x squared, where x is a 2, and then plus 8 times x, where again x is a 2, and then plus we have at the very end a 1. And let's simplify that to get the y value when x is equal to 2. 2 squared is a 4, so we have negative 2 times 4. 8 times 2 is a 16, and then we have a plus 1 at the end. And that gives us a negative 8 plus 16, which is a positive 8. and 8 plus 1 gives us a 9. All right, so we now know what the value of y is for the vertex. And let's graph that as a point. So the vertex is located at 2 comma 9. And let's see, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be where the vertex is located. All right, so from there, would 1 point be enough for us to graph a parabola? No. So back when we graph linear functions, to graph a line, 2 points are sufficient, which let me draw that out. If you have 2 points, that's enough for you to graph a line. What about parabolas? 1 point is not sufficient, but if we have at least 3 points, then that would be good enough, because if you have 3 points, one of which is the vertex, so that point and these 2 points over here, then we know what the direction of opening is, and we know how wide or narrow the curve would be. It would look like that if we have these 3 points. So the more points the better, but if you have a minimum of 3 points for your parabola, that's the beginning step of graphing quadratics. So let's get not 3 but 5 points. So step 3 would be to make a table of values. All right, so, and how do you make a proper table of value for quadratics? Well, you place the vertex at the exact center of the table of values. So the center of the vertex is at 2, when x is equal to 2, then y is a 9. And then from there, keep in mind that the axis of symmetry would be at the vertex. And from there, you want to get two values of x that are above 2, which 1 more than 2 gives you a 3, and then 1 more than 3 gives you a 4. And then get two values of 2 which are below 2, which 2 minus 1 gives you a 1, and 1 minus 1 gives you a 0. All right, so once you get your 5 values of x, you then want to choose either the top 2 values or the bottom 2 values. It doesn't matter which ones you choose. Choose whichever ones are more convenient. Since 1 and 0 are smaller numbers, they're easier to work with. Let's just choose those. All right, so all you do is you plug in for the value of x a 0, and then get the y value for that, and plug in for the value of x a 1 and get the y value for that. Which, let me put the work over here, so on the bottom. So when x is equal to 1, let's see what the value of y is. So plug in 1 for the value of x in place of every x in the original equation, which y would be equal to negative 2 times 1 squared plus 8 times 1 plus 1. And that gives us a negative 2 times 1, which is a negative 2, plus 8 plus 1, and that gives us a 6 plus 1, which gives you a 7. All right, so we know that when x is a 1, then y would be a 7, and let's put that on the table of values. And all you do then would be to reflect the 7 across the axis of symmetry. Why do we do this? Well, if you look at the graph, if 1, 7, which let's graph that, 1, and then 1, 2, 3, 4, 5, 6, 7. If 1, 7 is a point on the parabola, well then it's symmetric about the axis of symmetry, and if you were to get the symmetric point across from the axis of symmetry, then 3, 7 is also a point, and that's represented by the table of values as well. All right, so same exact process with the value of x of 0. So if you plug in a 0 for the value of x, then y would be negative 2 times 0 squared plus 8 times 0 plus 1. And that gives us a 0 plus 0 plus 1, and that would be a 1. There's the same idea with the 1. You would reflect it across the axis of symmetry. And let's graph the 2 points of 0, 1, and 4, 1. And that would be the graph of our parabolic function. All right, so it's a relatively easy process, just 3 steps. And there's a couple of calculations that we have to get in the middle, but that's normal for algebra. So, okay, so that's number 1. Let's move on to graphing a second quadratic. It's all the same process. If you just follow this 3-step process, then you can graph any quadratic if it's in standard form. All right, so now number 2. Let's graph y equals to 3x squared plus 12x plus 5. All right, so again, step 1 would be you want to get the x value for the vertex, which the formula would be x is negative b over 2a. And the value of b over here is a 12, right? So it's negative of 12 over twice the value of a, which is a 3. And that gives us a negative 12 divided by twice 3 is a 6. And negative 12 divided by 6 should be a negative 2. All right, so we know what the value of x is for the vertex and the axis of symmetry, which let me make the Cartesian plane on the right side. All right, so the value of x is a negative 2, which let me go up until negative 4 so we can see everything. So at x is equal to negative 2, we make a vertical dashed line to represent our axis of symmetry. And then from there, we want to plug it back in for every value of x in the original function to get the y value of the vertex. And y would be what? 3 times negative 2 quantity squared plus 12 times negative 2 plus 5. And let's follow what PEMDAS for this. So negative 2 squared would be a positive 4. And then 12 times negative 2 is a negative 24. And then we have the plus 5 at the very end. And that gives us a 12 minus 24, which is a negative 12. And negative 12 plus 5 gives us a negative 7. All right, so we now know where the vertex is located. It is at negative 2, negative 7. And we can pinpoint that on the graph as well. So negative 2, negative 1, 2, 3, 4, 5, 6, 7. And that would be where the vertex is located. And the a term is positive for this, so the graph should be opening upwards. Okay, so now from there, once you finish up step 1 and step 2, which are to get the x value and the y value for the vertex, you want to then move on to making a table of values, step 3. And let's make it here. So you want to place the vertex at the exact center of your table of values, which is negative 2, negative 7. And then from there, again, you want to get two values on top of the value of x, which would be negative 1 and 0. And then below negative 2 would be negative 3 and negative 4. Okay, so let's choose 0 and negative 1 just because they're more convenient numbers to choose. And let's get the value of y for both of these x values. So when x is equal to negative 1, then we have a y value of 3 times negative 1 quantity squared plus 12 times negative 1 plus 5. And that gives us a 3 times 1, which is a 3, minus 12 plus 5, and that gives us a negative 9 plus 5, and that would be a negative 4. All right, so when x is a negative 1, then y would be a negative 4, which again, you would reflect that across the axis of symmetry. And let's plot those 2 points. So we have negative 1, negative 1, 2, 3, 4, and we have a negative 3, negative 4, which is right there. And then if you plug in a 0 for every x, well, that should be easy. So we have y equals 3 times 0 squared plus 12 times 0 plus 5. And that gives us a 0 plus 0 plus 5, which is a 5. Right? So y would be a 5 when x is a 0. And they both reflect. All right, so we have 0, 5, which is, let's see, 1, 2, 3, 4, 5, right there. And then we have a negative 4, 5, which would be its symmetric point. And then let's try our best to make our curve, which looks something like that.